I'm near London. I'm investigating how can we discover new chemical entities to modulate biology. A main project in the lab is trying to find molecules that will inhibit a specific enzyme in the cell. We ran computer simulations trying to design such inhibitors, and then we went through an arduous process of sifting through different candidates coming up from the computer and selecting candidates that looks promising to us. And then we actually went ahead and synthesized some of these compounds here in our lab, in our own hands, and we tested those compounds, and one of them turned out to be a very, very potent inhibitor of our target. Specifically, our research actually deals with shortening the pipeline for early discoveries of potentially therapeutic compounds. We develop computer algorithms to help us identify candidates for compounds that would have some therapeutic advantage, and instead of screening them empirically or testing many different shots in the dark, we rationally design these compounds. If you can imagine the covalent bond like a glue that makes the compound just stick to its target, it means that it has a much longer duration of action. You can take a pill once a week instead of 3 times a day because it just sticks to where it's needed and doesn't dissociate all the time. You can use lower concentrations and have less side effects because each compound is very potent in and of itself. And also you can get specificity because these compounds only target specific residues in proteins. They wouldn't bind to other proteins that are similar but doesn't have this exact handle. There are a lot of advantages working in covalent compounds, and so far people kind of ignored them, and we bring them to the forefront.